Yes, great. All right, so my name is JAD, and I'm here to talk about modern web performance patterns. And a little bit about me, I'm a web performance consultant. I'm independent, so I work by myself. I sometimes go to companies, and I mostly run my learning platform, which one of them is Learn JavaScript.online. Just have to make sure the cat doesn't fall. And outside work, I'm a little bit known by my friends as JAD of all trades because I'm equally bad at so many sports, but I really enjoy doing them. You can follow me on Twitter, and if you like to stay up to date with my cat, you can follow me on Instagram. She was there skateboarding with me. And let's get started. So I want to cover four main topics today, all relating to performance. And this is a little bit of an advanced talk, so it does assume you already have optimized for Core Web Vitals. So if you haven't already optimized for Core Web Vitals, I would put all of these on the side, go with Core Web Vitals first, and then think about optimizing these things. So these really come later. Also, you don't have to use all four of them. You can combine them. They go really well together, or you can just use whichever makes more sense to your company or your website. So let's get started with early bottlenecks. So I want to cover two bottlenecks that I think we don't talk a lot about nowadays. The first one is time to first byte and large HTML file. So let's start with the time to first byte. This is a metric that measures the time between the request and when the first byte of the response arrives. So you open up your browser, type certain URL, hit enter. From that moment, assuming the browser didn't do any magic to already preload it, but yeah, so the moment you hit enter, we start recording until the first byte of the response arrives. So this doesn't necessarily mean, this actually doesn't mean you see anything on the page, but this time is what we call the time to first byte. Now, to be clear, this is not a Core Web Vital metric. So yeah, you don't really necessarily need to optimize for it to pass Core Web Vitals. So you also don't necessarily need to measure it. However, if you have a really slow time to first byte, then it's going to be catastrophic. It's going to have a catastrophic waterfall effect on your performance because, simply put, it's the first thing that's going to happen. And that's why I want to talk about it today. I also want to talk about some tips and tricks on how to make it even faster. So even if you don't have an issue with time to first byte, you can, in some cases, shave off 300 milliseconds or more. And yeah, in performance where 300 milliseconds is quite a lot. So let's take a look. So your goal, or your website's goal, is to show usable content on the screen as soon as possible, ASAP. And generally, this is not the only way it's done, but generally we have two spectrums. We have fast TTFP from one side and slow TTFP from one side. And a lot of JavaScript with fast TTFP or a little JavaScript with slow TTFP. So it's kind of like, if you want to have fast time to first byte, you're most likely going to have a lot of JavaScript, or slow time to first byte, but a little JavaScript. It's not necessarily like this, but in general, that's how we see it. So yeah, it could be on both sides of the spectrum, but it doesn't really have to be like that. In some cases, you really are able to have the best of both worlds, and that is fast time to first byte and little JavaScript. So how do we do that? Again, it's not always possible, not always feasible, but in a lot of cases, you can do some changes, tweaks. And to show you how, I'm going to start by showing you something that looks a little bit off topic, but that's the population density of the whole world. I'm going to give you a few seconds to process it. So you can see, yeah, in Australia, most people are on the western side. You have also on the eastern side, China, India, Indonesia, some hotspots in Africa, Europe, and the Middle East, the Americas also. Now, if you compare this map to this one, which happens to be Cloudflare's Edge network. Now, this is not an advertisement for Cloudflare. You can use any other CDN like CloudFront as well, for example. And yeah, I'm gonna shuffle between these two images. Take a look. So we've reached a stage where we have an edge network close to almost every single, the majority, like maybe 90% or more of users in the world. And that's amazing for cutting latency time, which is also important for reducing time to first byte. But the thing is, many people use Cloudflare, but you have to be aware of something, that by default, Cloudflare does not cache HTML files by default. So actually, if you do put Cloudflare, you may be making it slightly slower by a little bit, because the request is going to go through the Cloudflare edge, and then it's going to have to go all the way to your servers. And it doesn't cache it. I'm talking only about the HTML file. For other resources, it will cache it. But your HTML file, the one that is responsible for the TTFB, and when I say HTML, it doesn't have to be an actual HTML file. It could be Ruby, Python, PHP emitting an HTML file output. But yeah, so Cloudflare by default does not cache it. You can see that by inspecting the response headers, and you'll see that it's not a cache hit, but it's rather a cache miss. But what you can do instead, you can actually cache HTML files using page rules. Now, you do have to check if that's okay, because you don't want to cache pages where the user is already logged in and show that to other customers, or if your content changes every hour or every day. So you really want to check that. But I would recommend as much as possible to be aggressive on the caching whenever possible, especially for landing pages, for pages that don't change. And you can write a script to clear this cache. So you can clear it hourly, you can clear it after deployment. But yeah, I really recommend you check out how you can cache HTML files on whatever CDN you're using, because by default, they will not cache that, because it could risk really messing up the output. You can also use edge workers. There's an asterisk here because I've never done it yet, so I do want to tell you about that. And it also might require quite some re-architecturing of your app. So yeah, and also, like, I wouldn't really push everything on the edge if you can do some other performance optimizations. So I would keep this until the end. So that's for the time to first byte. And then I want to talk about the HTML response. So when you connect to a server and you get back an HTML file or the HTML response, this is our next bottleneck. And I want to tell you that browsers really struggle a lot with larger HTML responses. And the thing is, most speed tools don't really warn against that. So Lighthouse has a rule that warns against a large DOM, but that's different than large HTML file. So because you could have a large HTML file with a smaller DOM size. For example, if you have a very large inline SVG. So yeah, I've spent countless time with clients where we're looking at a performance issue and we really can't find anything. All the tools are not saying what's wrong, until you really inspect it and see that we have a 400 kilobyte HTML file, and that's really the big bottleneck. So the browser it seems like the browser it's not really meant to process these big HTML files. But of course, don't reduce the amount of HTML to add more JavaScript, because JavaScript is going to cost even more. So what are the common mistakes? Well, the most common mistake that I've seen is inlining large SVGs. So sometimes you have to inline SVGs, like a logo, maybe an icon if it's above the fold, or maybe you want to do some use CSS variable with that icon, and you are forced to inline it. You really have to be wary about that. So don't inline anything more than 3 kilobyte. This might change depending on your circumstances. And yeah, sometimes like I've seen it in many websites, they say we accept, and then you have like all versions of credit cards and debit cards, and they have icons for them. And they're all innocent, but one that is 50 kilobytes. So you really have to be wary of that, because 50 kilobytes in an HTML file is really a lot. The second thing is, this is especially if you're selling a product or have a list of repeating items or repeating cards. Let's say you are selling keyboards and you have 50 types of keyboards and you have like a favorite icon for each keyboard. And this is all showing on the homepage. The problem you're going to have here is if each favorite icon is 3 kilobytes, you're going to have 50 times 3, that's 150 kilobytes just for one single icon. So it's really unexpected sometimes that you wouldn't think that this small thing could be causing a big performance issue. And the solution here is mentioned number 3, is that you can actually use, it's going to be tricky to say, you can use SVG's use element. So this allows you to define the favorite icon once, and then later you can use it and point to the ID where it was defined. So you only define it once, that's 3 kilobytes, and then you use the use keyword 50 times, and that's going to save, in that case, 140 kilobytes, which is amazing. And yeah, sometimes it's really beyond your, sometimes you really have to discuss with stakeholders and you have to tell them like, hey, this, this 2 kilometer long landing page doesn't make sense because of performance. And I understand that sometimes that's tricky. If you feel that people are not convinced, try to get another performance, an external performance consultant, because it's often easier to convince stakeholders, especially because the stakeholders are paying for it. So they really want to take whatever advice they can get for that session. So yeah, that was the first part about early bottlenecks. And now I'm going to talk about a technique I'd like to call hyper-optimized landing page. You will probably not find that name on the internet. And it's not like I didn't invent it, but this is how I like to call it. And this technique makes a lot of sense for a lot of websites. It's because many websites really start with a landing page that the goal of it is just to have the user's email or to have the user sign up or start a trial or book a demo. So many websites have a, so what is the hyper-optimized landing page? Well, it's a landing page. It's a normal page that is extremely optimized for speed, like really extremely, you're going to see. And at the same time, it's also optimized for a high conversion rate. So there's generally 1 or 2 actions you can do, either sign up, enter your email, or do one of those things. And by over-optimizing it, by hyper-optimizing it, we can really get the first page load to be faster than 1 second on desktop. You can, depending on your use case, but depending on what you have, but you can even get it to load in as fast as 400 milliseconds on desktop and around 1.3 seconds on mobile. I think this is very clearly going to have great great benefits for user experience and SEO, especially if you're selling a product, or your users will also be very happy. Like they write the domain or click from a search engine, and then less than a second it loads, and that's really going to have a very positive impact. So how do you optimize it? And this is where it's going to sound a little bit crazy, but if you have a massive application, the landing page for it should not have any framework. So if you're using React, you're using Angular, for the main app, I really recommend you handwrite or you separate the landing page, because most landing pages are more or less static. They might have a list of featured products, yes, that changes once a week. They might show a little icon if the user is logged in or logged out. But in general, you really don't need a massive framework for the landing page. But the visitors are actually paying quite a big cost to visit landing pages just because of the complexity of the rest of the app. And this is what I'm kind of trying to preach in this hyper-optimized landing page. So separate your homepage as much as possible. On the extreme side, I would go with no framework. I would write it by hand if necessary, and I would inline the styles necessary for this page, as long as they're less than 10 kilobytes in the head. So you don't even need to fetch a CSS file if possible. That's really hyper-optimized. I would also not load all the fonts you use in your app, just only the minimal fonts. and I would delay the third-party scripts if possible. Altogether, skip them, but I know that's probably not possible. So I see there's a lot of questions, but I think you'll tell me about them later. So if you work at a company, you're probably thinking, have you lost your mind? No one's going to accept that. And this is obviously bad for code duplication because you have a UI kit, and on the homepage, let's say you have a UI kit written with Angular or React, and on the homepage, you suddenly can't use it. So I do realize that this is against what we usually recommend for code duplication. And yeah, if you want to show, what about some interactivity? Like if you want to show that the user is logged in and you want to swap the login to continue or these kind of things, you can still do that by storing some data in some storage like local storage or cookies, and based on that swap the elements. You will have code duplication, I understand, but it all comes down to the fourth point: is it worth it? And in many businesses nowadays, performance is paramount, it's very important. Maybe yours isn't, but if like most of them, performance is important, then yeah, it's really worth having code duplication, in my opinion. So you still have to educate the team about it. You still have to have comments and notes. You could automate it, but it's depending on how much it's worth it for you. So yeah, at the end, the landing page would be really going back to basics. It's just an HTML file, and it's a yeah, you have the critical CSS in the head, maximum 10 kilobytes, and you have the rest of your HTML, or it could be pre-rendered. So you can pre-render, like depending on your website, but you can either pre-render it on deployment or every hour, depending if things change every hour, then I would pre-render a static version every hour. But yeah, also don't have a massive HTML file like we discussed, because that defeats the purpose. So yeah, again, I do understand that this is an extreme optimization technique, but if it's worth it for you, you will find out that it's really worth doing. And you don't have to go all the way extreme. You can pick the relevant learnings based on your use case. So at minimum, you can at least separate the bundle, the JavaScript bundle, for the landing page, because I've seen so many websites where in the main app they have a carousel library and they have like a dialogue library, but all of these are not used in the landing page. So in that case, you really shouldn't be loading these on the landing page. But this is, I would say, the minimal. I wouldn't call it hyper optimized in that case. But I really like this technique because it actually lets you to go a step further. Because theoretically, we now have a page that loads in around 1 second. And the user is going to visit this. It loads in less than 1 second or around 1 second. And the user is most of the time going to spend some time reading it, scrolling, reading the content, checking the images, or maybe the video. And we can use this idle time actually to make the remaining pages faster. The thing is, we can have a hyper-optimized landing page, but your main website, your main app still requires many resources, maybe even large libraries or large SDKs that we have to load. But yeah, you can use this idle time because we have instant loading for this page, more or less. We use this idle time to make it even faster for subsequent pages. So how do we benefit from this idle time? Well, we can prefetch the following page or the following resources. So maybe your website is really linear. So you go on the landing page and then there's only one page you can go to, or maybe there's 3 pages, but they all share the same resource. In that case, we would preload the resource. And I say prefetch with an asterisk here because I'm not necessarily only referring to link rel prefetch. That's one of the options, but I will talk about the options in the next slides. So yeah, there are many ways to do it, and you can like preload your commons chunk or some important SDK you have to use later on. So yeah, I like to call this that you are kind of installing the app resources in the background, just kind of like how you visit the App Store and you click install, but when you click install, you only have a loader. The difference here is that You land on the landing page, and in the background, you are installing the app resources. But please don't make that if the user has data saver enabled, because if they're visiting a very fast page, you don't really want to install 5 megabytes of resources if they have data saver enabled. This is why I'm showing you here how to check for the data saver mode, and you only install the service worker if data saver is not enabled. And also this, like, make sure the service worker you're generating, make sure to every time you make changes to it, to check which chunks end up in the service worker's manifest. It's easy to end up with map files. It's easy to end up with some scripts you never really use. So make sure to inspect that. So yeah, I also didn't mention it, but this assumes you already have a service worker, and the service worker usually has all the JavaScript chunks and all the libraries you use. So by installing it, you will have them already in the user's cache. And that's going to be really cool because it's going to load faster. There are alternative approaches. You can use link rel prefetch to specify a certain URL if you know which URL the user is going to visit next. Even better, you can use the speculation rules. And here's a link for it, but this has lacking browser support. And so yeah, this is better, but at the moment, I think this is Chrome only. I'm most likely Chrome only. All right, shall we take some questions already or continue? Okay, let's continue. So next up, I want to talk about loading large SDK, because there are some use cases where your company operates while really needing a specific SDK that weighs more than 500 kilobytes. This could be like a cryptographical SDK. This could be an SDK from a certain cloud provider. And 500 kilobytes of JavaScript is a lot, but you're not really doomed. And that's kind of what I want to show you. Now, there's two sides of this. Throwing 500 kilobytes at a browser, especially on mobile device, will most likely freeze the browser for a few seconds. But this is what the SDK itself should optimize. We can't really optimize for that. What we can optimize is the loading of this SDK so that our website doesn't really, well, I won't say freeze, because we want our website to load first so that the SDK can load later, maybe even allow the user to interact with the rest of the app while it's loading. So sometimes you can use the hyper-optimized landing page solution like we discussed, but that's not always possible, because sometimes you have two versions of these SDK, and only at runtime you need to check, like, is the user on this platform or that platform? Are they on mobile, on tablet? So sometimes it's not possible to use the hyper-optimized landing page. So what's the strategy here? Well, the most important thing you can do is you will need to remove the SDK from your main bundle. So you want to remove the static imports and replace those with dynamic imports. You want to use import as a function, because the moment you use import as a function, you are removing the SDK from your main bundle. So your main bundle goes down from 700 kilobytes to, let's say, 200 kilobytes, because you remove this 500. We still load it later, but this allows your website to load faster. The SDK hasn't loaded yet, but if you do your UI properly, then this is actually a lot more acceptable than having your website wait for so long on a blank screen or just on one loader. So the strategy is get your web page to load as fast as possible and show a hint to the user. Tell them what's going on. Tell them we are loading, and then if it takes more than 3 seconds, so on desktop, it's probably going to load really fast, but on mobile or on slow connections, you can detect that. You can tell the user after 3 seconds, just probably too long, but you can tell them like, hey, we know it's taking too long, but we are actually still loading. So they understand that it's not stuck. It might take a few more minutes, but yeah, this is too long. Just say it's still loading. You can also detect if the user is on a slow network. In that case, maybe it's possible to load a smaller SDK that is not ideal, or just show a message saying like, hey, this might take up to 30 seconds. It's not ideal. Again, I understand. Nobody wants to see a message that says it's gonna take 30 seconds. But we're handling, really slow networks here. I'm talking slow 3G. And most importantly, please handle failures, because dynamic imports can fail. So you can show a message that this has failed. Ideally, you'd even allow retries, either a retry button to recall the function that had the dynamic import, or worst case scenario, just a way to reload the entire page. So the code for that would be, for example, you start the loader, and then with set timeout, we delay this code to 2,500 milliseconds, so 2.5 seconds. So after 2.5 seconds, if it's still loading, we change the text to still loading. So we tell the user like, hey, we know it's taking time. It's gonna take a little bit more time. And then you import, dynamic import, large SDK, this large SDK, and you handle the success with .then, you handle the error with .catch, and with .finally, which is gonna run in both cases. So after the .then or after the .catch, we clear the timeout so that after it loads, and if it loaded within less than 2.5 seconds, then we don't really show this loader message. So this cancels the timeout. This is, of course, a very simple code. It will get more complicated with the real deal, but the most important thing is the dynamic input. And I don't know if you can hear it, but my cat's been meowing the whole time. And this is the code that you can use to detect the user's slow connection. This is checking the downlink is less than 1 megabit per second. You can update that, but you can even make a bit of calculations. If you really have to load something very large, you can predict how many seconds it's going to take, more or less. And this is an example where the page is loading, and after 2 seconds or 3 seconds, it says still loading. I'm gonna replay it one more time. So loading, and after 2.5 seconds, it says still loading. So yeah, you can take this further. Again, you can handle if it fails with the error message and the button, and maybe you can even handle really, really long loading times. And the last thing I want to talk about today is long tasks and prioritization. And yeah, so in performance, a lot of performance work is really prioritization. So it's sometimes a bit shocking to people, but the same amount of code can run faster when you prioritize certain tasks or when you have a more correct prioritization. So a lot of the times I'm really shuffling elements or shuffling scripts to get things to load faster. Also, sometimes adding a little bit more code can make things faster, but it depends on what this code is doing. And what I want to try and tell you is that I'm going to teach you about the tasks API in a bit, and you're going to see that we're going to add a little bit of code to something that already exists, and that's going to make it run faster, just because it's really hooking to how the browser is running JavaScript. And I do have a quote here from Paul Lewis from maybe 6 years ago, that performance is the art of avoiding work. So, of course, I really love this quote, that if you can avoid running work, please avoid it. This is the first thing you should do with performance. But this talk assumes that you really cannot avoid it, and trying to show you some ways to still make it faster. So JavaScript has the run to completion model, which means the current task is always finished before the next task begins. And in that case, when you call save settings, it's going to call validate form, show spinner, save to database, update UI, and send analytics. It will wait until each one of these is done. And the browser can't really take a break in between. So this actually looks like this in the browser, in the DevTools. We have this massive task, and the user clicks, and on click we call save settings. And inside of this save settings, it's made up of validate form, show spinner, save to database, etc. But if the user types in between this task, then the browser cannot update it. If there's a video playing, I think it's going to freeze. Nothing else can happen because the main thread is completely blocked. And yeah, that's not going to be very nice for the user experience, because the browser is just frozen for, if this is taking 200 milliseconds, then for 200 milliseconds. Even the frames are missed, so the browser can't really paint the next frame on the screen. The solution would be to chunk these up into smaller tasks, and even more ideally to communicate the browser the importance of these tasks. And there are multiple ways to do that. You can do it with set timeout. This is not recommended, but I'm just telling you that if you had set timeout on one of these, then it will be queued at a later time. So it will not be, the function within set timeout will be taken out and it's not part of this long task anymore. But I wouldn't recommend using it for this purpose, to make it faster. You can also use request idle callback, but that's a little bit more tricky because you get around 50 milliseconds before the browser paints the next frame, but it's not always 50. It could be less. You could check it with the argument, idle deadline, by calling time remaining, but it's quite complicated. Ideally, you would use the post-task API, but this is a very new API. But they do have a very good polyfill. But check browser support and check the polyfill before using it. And if we take the previous code, which had only validate form, show spinner, and we call this, I'll talk about the syntax in 3 slides, but we wrap them with scheduler.postTask and pass it as the first argument for all of these 5 functions. And we give them different priorities. So the first 2 are user blocking. This is the highest priority. It means they are blocking the user's action. So we have to really process these tasks as fast as possible. However, save to database is in the background, and this is the least priority. But then update UI is user blocking, and then send analytics is also background. So you tell the browser, because the browser might be too busy right now, it will still proceed with the user blocking task, but it can queue the priority one, the background ones, for later, so it can delay them a little bit. And that's what's nice about the API, because we have no direct way of knowing if the browser is busy or not, or at least straightforward way. But this is really just offloading it to the browser. It's amazing. And this is what you get. The task gets broken up into 5 tasks. The order might be different, of course, because the user visible are more important than the update UI. This is not reflected in the image, but also I wouldn't say it's necessarily consistent. It depends on what the browser is dealing with at the moment. But the nice thing is that, and you can see it between validate form and show spinner, there's a tiny bit of blue work. So if the browser had to do something in between these 2 tasks, it can do it. And so if the user types something, the browser can process it. If there's a video playing, it will continue playing. The next frame will be drawn, and that's much better. This is what we call yielding. We are yielding to the browser so that it continue doing its work. And this is a before-after comparison. We went from 1 large task to 5 smaller tasks. Now, it may be tempting to just go change your entire application to use post task for every single function call. I haven't tried that. It's probably not a good idea, but I've mostly, I would use it mostly if you know something is very slow, like a certain function call is very slow or is doing a lot of things and you want to break it up, then that's a good use case. Overall, across an entire application, it's still possible and you are encouraged to use it, but I think you have to think a little bit more of a strategy on how to use it so it doesn't get very messy. And yeah, to break down this API, it actually accepts 3 priorities, but I've only shown you 2 before. So from high priority to low, user blocking, user visible. So it's visible by the user, but it's not blocking. It's not very important. And the least is background. You can also specify a delay in milliseconds. I would do that for analytics. Like, yeah, this is in the background, but you can do it in 2 seconds. It's not very important, or 3 seconds. So yeah, don't forget, this requires a polyfill. The API also supports more advanced use cases, like when to yield to the browser, and is still being improved. So I would keep an eye on this one. And yeah, that was it. We covered 4 things: early bottlenecks, the hyper-optimized landing page, and you can see why they work really well together. Assuming you have a really fast time to first byte, a small HTML file that is hyper-optimized, then already your landing page loads really quickly. And then maybe you can use that technique to load the large library that you need later on. If not, you can apply the technique we talked about. And whenever you have long tasks, then you can also break them up in small pieces so that your runtime performance is actually faster. Thanks so much. I hope you enjoyed the talk, and I'm curious about all the questions.
Hey, thank you so much for that. That was an amazing talk. I appreciated the way it was structured and also how you kind of wrapped it up at the end. I really, really enjoyed that. There's so much meat. Yeah, for sure. Also, the audience has left a lot of questions in our doc. If you have questions still, we invite you to add them as I ask them. But we'll spend a few seconds here just kind of talking about your talk and adding some questions. The first question comes from I don't know who. If you want your name included, by the way, in the Q&A, just leave your name in the Google Doc as well. But the first question says, is the HTML size bad in general, or are there any other considerations? Like, does DOM tree complexity have a role in loading time in your experience? And I think, just listening to your talk, you kind of answered that there are other considerations, but I'm gonna let you elaborate on that.
Yeah, that's a very good question. I wonder if I can actually answer it with very clearly and not say it depends. But let me read it one more time. So is the HTML size bad in general, or are there any other considerations? So DOM tree complexity is definitely bad, but I'm not sure if it's really how bad it is for loading time, because the bad thing about DOM tree complexity is that it's going to make all the updates slower later on. And the thing with DOM tree complexity is that it might start as, maybe you might start with 1,000 element, but then you click on the sidebar and that loads the sidebar and that has 1,000 extra elements. So it might actually only become complex a few seconds or a few minutes if you have a long-lived application. So I will come back to it depends. In general, you want to have both as low as possible. But yeah. It depends, but it's a really good question. Yeah.
Just to extend this question a little bit, if I could, summarize 3 things to pay attention to where performance kind of falls apart. Obviously, like DOM tree complexity, you spent some time talking about this, including the use of the use element in SVG and so on to remove redundant elements, right? So if we were to summarize
the HTML response more than the DOM, Right.
If we were to summarize 3 things from this, so the HTML response being nice and small, what would the other 2 be that you would tell developers, like, pay attention to this because I've seen this go wrong multiple times?
So in the HTML response, other than SVG, you mean?
I don't mean in the HTML response. I mean the HTML response being one thing to pay attention to, the size of it and the complexity of it. What are 2 other things?
So in general, for web performance?
Correct.
Okay. Also, nice question. I will assume that like files. Okay, yeah, I do have one, but I will just assume that like files have been minified, and then you have the cache headers set properly. I would say just not inspecting your bundle because no matter how good of a developer you are, things will unexpectedly end up in your bundle just because of the way import works, and each project has hundreds, if not thousands, of files. You really have no idea what ends up in your bundle. So just use Webpack Bundle Analyzer or any equivalent for a Vite. Lighthouse, PageSpeed Insight has one. It may not give you like a big breakdown though. I think only if you upload the source maps. But so I've been to with many companies. The first thing we do is look at the bundle, and they tell me like, "Oh wow, I really had no idea this was in the bundle."
Wow. That is a really good insight. So always check your bundles and know what's happening. This reminds me of NCDU. I don't know if you've used NCDU it's a brilliant command line tool which will show you not bundles and dependencies, but more sizes of things on your file system. And you go, oh my gosh, it's a 25 gigabyte PDF. Well, I didn't know I had this. So that's really valuable. To extend that, do you then suggest including source maps with production sites or no? I mean, there's trade-offs to this, right? It becomes more debuggable. At the same time, also users don't necessarily download them. So where do you stand on that?
I think I personally do ship them, although they can get quite large. I think with every deploy, I do 1 megabyte is source maps, because I do have like quite some large files that are loaded. Yeah, I guess in general, it's nicer to have source maps, because when you get this error on Sentry or whatever error reporting, you can really know what it means, other than cannot call n._a, which is like the function after it's been minified.
Yeah, awesome. I see another question here from someone. Again, if you want your name mentioned, please add it. That first question, by the way, was from Kirill Mishkin. Thank you, Kirill. The second question is about compression. Because when the HTML complexity going over the wire is pretty long, even with Java, anything textual really, there's an element for gzip or Brotli or other compression techniques. This question is pretty open-ended, but it's about what is the role of compression in this context, and what compression mechanisms or algorithms do you personally recommend?
Okay, this might sound cheesy, but I really love this question, because I will assume you are using Brotli, which is I think the one that's going to compress the most. But this is only for when it's in transit. So this only from the server to the browser. But after it arrives to the browser has to decompress it. So if you had a megabyte and you Brotli it to 10 kilobyte, that's not possible. But even if you did that, the transfer will be pretty fast, but then the browser still has to deal with a megabyte of something. And this is why when I talk about performance, I usually go with minified. I like to use the metric minified, because that's the one the browser is going to deal with. The others are for network, and yes, please do use at least gzip if you can Brotli.
Awesome. But of course, to handle these, we would have to go beyond the front end with JavaScript and really control the server to send these headers.
Yeah, but with CDNs, it's with a check of a button, which is quite nice.
Nice. For those of us purely on the client side without access to CDNs, if I understand correctly, you would recommend then really taking care of your bundle sizes, your imports, and keeping your HTML as small as possible.
Yes, but I think all the servers, like the providers, will at least give you gzip. Should be out of the box, unless you're configuring it by default. So it should be relatively now easy to have gzip. Brotli I think Brotli has quite some wide support even.
Awesome. I personally
I think you can check it.
I personally like Brotli, not because it's so good, but just because it sounds like broccoli. And I really enjoy eating broccoli. Hey, that's all the time we have for questions. Thank you so much, JAD. Can you give it up one more time, everybody?
I'll be back on the